Well, hello and welcome to another DevNation Live Tech Talk. We're going to be coming at you for the next 30 minutes or so, and we're going to be talking about Helm and the Operator SDK. It's going to be a lot of fun. I hope you give us some questions in the YouTube chat. Just throw them in there, and I'll relay them to Daniel as he gets through his presentation. But also, we just love chatting with each other, and you can see that we have DJ Maddie and James there and Chris Gunn. Good to see you guys again. If you're in the chat with us right now, feel free to throw your name in there and let us know you're here. But we're going to be talking about Helm, Operator SDK, and having a lot of fun with that. Let me turn it over to Daniel right now. So Daniel Messer is going to walk us through this presentation. Daniel, over to you.
Hey, thank you, Burr. It's so nice to be here. I'm super stoked to be in the famous DevNation Tech Talk series, finally. So hello, everyone. Thank you for joining. My name is Daniel Messer. I'm a product manager here at Red Hat. And, I got to talk to Burr lately about something that I also saw, which is seems there is a heated debate going on that, should I use Helm or should I use operators? Which one of those is the superior technology? So that's kind of what I'm going to try to shed some light on today from the inside as I'm working in that space. So I'm quickly going to share my screen here for presentation and then a demo as well to give you a little bit of perspective on that topic. So Helm or operators, or how you can have both. Just told you I'm working on Red Hat. I'm working on something that's called the Operator Framework. That's an open source project that we have that aims to make developers happy in writing operators and make cluster admins happy in running operators at scale on Kubernetes clusters. There's also the community hub around operators, sort of the registry for operators at operatorhub.io. And I'm also looking after the Quay registry open source project as well. I'm doing this since a little bit more than 1.5 years now, and it's been really exciting to see this growth in the ecosystem on the tooling side for operators with things like KubeBuilder, but also what we do with something called the Operator SDK, and obviously the maturing ecosystem of operators themselves that can really do a lot to provide managed services basically wherever your cluster is, right? So been a Red Hatter since 2014, been with Kubernetes since OpenShift made the famous switch from version 2 to version 3, which rebased entirely on Kubernetes, and been with Linux for a very long time now. So I think since the early days of Fedora Core 2 was my first desktop distro. So you've basically come across this as well, most likely in the recent past. Either as a developer looking to develop an application and you quickly need some sort of backend service stood up in your test cluster or development cluster, might be a database, message queue, or something like that. And you have the choice between, using one of the many Helm charts out there that are packaging these up ready to go and install in your cluster, or install an operator which gives you that managed workload in an as-a-service fashion. Right? And with that comes this sort of discussion that we've recently seen whether or not one is the right choice. And, guess what? I'm wearing my Helm Summit t-shirt today from Helm Summit Amsterdam earlier in order to kind of throw you off a little bit of the base here that you can definitely have both, right? And both have their unique advantages. And it's as always, right? You choose the right tool for the right task and the right technology for the right task. So Helm is super popular and has been around for a very long time. Operators are somewhat newer, but also keep maturing. So what if I told you that you can actually use both technologies, both approaches at the same time, and get some of the features and advantages from both these technologies? So that's what I'm going to show you today. And I'm kind of going to assume that most of you have seen Helm or have used Helm in the past, at least for once. So I'm going to just do a very quick refresher on that, then compare that to how operators work and show you how you can use that in conjunction with each other. So if you don't know, Helm is a package manager for Kubernetes. It's basically there to provide an easy way to get installations of applications done on Kubernetes as fast as possible. And it's essentially done by collecting all the templates of Kubernetes objects that make up an application or service on the cluster, and combine it with a templating language. So you can, adjust that a little bit as you go and deploy it on your cluster. That thing is called a chart. You can download them as a user on a chart repository, as a developer, software developer trying to ship your software. You can also write your own charts and publish them to a repository of your own or to the official Helm hub. And then you use the Helm CLI as a user to fetch that chart and install it in your cluster, which eventually creates Kubernetes objects, right? So in the back, normal Kubernetes business happening as usual. So what's happening under the hood is that you have these charts, right? These are templated kube manifests, if you will. And then you have values, right? Standard values that these charts use to fill in things like replica counts, image strings, and so on. There's also conditionals, so you can do some more fancy stuff to, render templates in different ways depending on the values. And that's done at the Helm library level, right? So when you call the Helm CLI, there's a library that parses the templates, the config values, renders the final Kubernetes resources, which it's then deploying on your cluster with some metadata next to it, which is usually deployed in a secret or a config map. That thing is called a release, and that's how you deploy software in Helm. Now, let me actually quickly do that myself in a little demo environment that I have here. So I'm going to switch gears real quick to my console window. I have an OpenShift cluster here. I'm changing a project which I prepared to deploy a Helm chart of a software called CockroachDB. Now, I've selected this particular Helm chart because on the one hand, I'm a big fan of CockroachDB. It's a super nice scale-out SQL database as a compliance, so it's really enticing from a technology perspective, and it's also almost self-managing, right? Which makes it perfect to be run on Kubernetes and packaged up in the Helm chart. So in order to just use a chart, I'm going to just pull that chart quickly down on my system and expand it on disk with the Helm pull command. You see here in that subdirectory, I get a cockroach folder stood up. In the templates folder, I have the chart. That's all the resources that the chart consists of and will eventually get deployed on my cluster. Some metadata in here, README, and a values.yaml, which provide the default values of that particular database cluster configuration. So CockroachDB is deployed as a stateful set, and by default it uses free replicas. So that's how my cluster will come to life in just a second. So if I were to use that as a user, I can just simply say Helm install. I give the location of the values.yaml. This is just default one that I just downloaded. I give it the name of the release, so that's the deployed instance of the chart on my cluster, and I give it a folder where it can find a chart on my disk, right? So kick it off, and it's going to deploy that in the background, and I get greeted with a welcome message that CockroachDB can now be accessed via this particular port at this particular services DNS inside the cluster backed by a service object. And there's even a command here which I can conveniently use to quickly log onto the database. So let's do that in a second. Just let me show you that stuff got created in my namespace. So I have a Cockroach database running as a cluster of 3 nodes, 3 pods here. I have services, the stateful set controlling the pods, and a batch job that was probably used to initialize the database. All right, just quickly see if that database is actually functional. I'm going to log on in an ephemeral container that contains the Cockroach client. And if it's not too early, I should get a database prompt back in a second or so, which tells me that I can actually use this from a production perspective. So I was probably too early. Just let me cancel that real quick and try it one more time. Delete that pod here. And just trying to connect to the database one more time and show you that this chart is actually usually working. And there it is. I have the database prompt. I can now just write database commands like show me all the databases inside, and I get a response from the system back. So clearly that CockroachDB cluster is up and running. Now you see how easy this was, right? So this just took under a minute in order to download the chart and instantiate a fully running cluster on my system. Now Helm even allows me to modify this in a limited extent. I can basically go back here to my values.yaml and just say I want to increase the replica count from 3 to 4 by manually editing this file, saving it, going back to my terminal and saying Helm upgrade. It's almost the same as the install command, but what it's going to do is going to search for that existing instance of the chart and modify it to contain that modification. So I again get that welcome message, but what actually happened is I got an additional node deployed as part of that cluster. So it's even possible to modify existing deployed software in the boundaries of what onboard Kubernetes features give you. So that's how people are basically installing and updating software using Helm. They are, changing configuration within the allowed bounds, and updates are usually coming down to changing image strings in the values of YAML to make the thing use a new container image containing a newer piece of software. All the logic to, migrate old schema information or old configuration is then usually encapsulated in that binary or software that you're deploying with the chart, as it's the case for CockroachDB. So this is super straightforward, and that's why developers love it, because you can quickly do this on your local machine in your local cluster with nothing else installed than the Helm client. If you know where the chart is and how to configure it, you're done in under a minute. Now, I'm going to be a little bit mean to my Helm chart here, and I'm going to try to sabotage the deployment. So that chart actually deployed two services, one of which is very vital for that connection test that I showed earlier, public ingress point for all the database connections. So if I would just now go in and simulate a rogue user or automation that accidentally or incidentally deleted that service, it would be gone, right? And that would prevent any kind of client in the future to connect to it. And while the database is still up, the pods are still here, the stateful set is still alive, so everything looks good. Even from the Helm perspective, everything looks okay, so it's still deployed. And if I do a Helm status, it still tells me everything is happy. It's at revision 2, so you shouldn't worry. The database isn't actually usable, right? And while this is not a very common scenario, it shows that Helm's view into the software really ends after the deployment. It's actually not really application aware. And it can't tell you if that database is alive or if it's actually usable, right? You kind of need to do that yourself. But all the other stuff is kind of working, right? So this lends itself pretty well to things like stateless applications. So if you talk about scale-out databases, that would be kind of an in-between. But stateless applications that don't really need like any of these day 2 operations, like backup, restore, failover, can easily be expressed in Helm charts. Anything that can be installed and updates with just Kubernetes onboard features is super suitable for Helm. Any update procedures that are happening are supported and will work as long as they don't need to kind of consider the internal state of the app, which is true for CockroachDB. But if you are looking at the CockroachDB Helm chart README, you'll see that it's not quite as straightforward to update the thing. So yes, it comes down to an image replacement, but before you do that, you actually need to log onto the database, set these downgrade option settings, and then also delete that job that got created by the Helm chart before you're actually able to run the Helm upgrade command to update the image tag, which contains a newer version of that particular database software. So kind of works almost entirely through Helm. Just at some points, you need to be really careful when there are changes to the chart itself. So especially the CockroachDB chart had like a disruptive change going from version 2 to version 3, where if you just updated to the chart, you would basically lose the database content, right? So that's where, the day 2 capabilities that are super important for production environments where the workloads run for a long time, most likely in a multi-tenant environment, are somewhat hitting their constraints, right? But nonetheless, this is super awesome for dev environments, and also in clusters where you're basically alone and you're cluster admin. Most charts actually assume you have quite significant amount of privilege in the Kubernetes cluster, and that's because in the previous version of Helm, there was a component running inside of Kubernetes that did the things for you, and it ran usually as cluster admin. Now that component vanished. It's now only the Helm CLI. So the Helm CLI, when I used it to install a chart, just used my Kubernetes connection information and credentials and assumed my user account. And many charts still assume that you can do things like storage class creation or other global objects, which you might not be having just enough permissions for in a production cluster in a corporate environment. That's where operators come in, right? So they try to extend that outreach in terms of managing the application beyond day 1, and they focus on day 2, right? So what they are basically looking for is to not only instantiate an application, but to actually manage it throughout its lifecycle, throughout all those updates with regular things like backups, failover, failback, recovery, and so on. And they do this taking a little bit of a different approach, right? Operators are basically pieces of software running in your cluster, which contain the best practices how to install and run that software, codified in a binary that runs inside your cluster and has access to the Kubernetes API and reacts to your requests. So the operator is application specific and it knows how to deploy a particular piece of software, right? In the end, it also creates Kubernetes objects, absolutely true. But it does this in a little bit of a different fashion, right? It does this in a continuously running software loop, which constantly watches the cluster. So what you're seeing happening under the hood is once you have such an operator installed in your Kubernetes cluster, you can see new resource types popping up. So as you have resources like pods, services, deployments, config maps, and so on, you now have a new resource called my database, right? And it's a Kubernetes object like any other Kubernetes object. So it has a kind, API version, metadata, and spec, but it's specific to the database that it represents, right? So it's a way for the user to ask the system for a database. And the way the user asks the system for a database is with regular kubectl tooling, the regular Kubernetes API, creating objects like they have always been doing, just this time specific to a database. And there's a piece of software running inside the cluster watching for these resources getting created. And once such a resource appears, it starts to run through a software loop in which it will continuously look at each of these specified configuration items for that particular database, like the version, replica count, and connection pool size, and make sure that whatever is necessary to deploy that on cluster is actually happening, right? That just doesn't do that once, it does this all the time. So whenever you update something here on the left-hand side, it'll find its way over into the change in the right-hand side. Similarly, if you remove something on the right-hand side that makes up your database, like a service or a config map, the operator will notice that and will see the difference between what's happening on cluster and what you specified in the custom resource, and it will revert that change. So it will recreate that. So that's what gives us the ability to do really important things like data operations for applications over time, right, as these applications continues to run. So this is important for stateful applications like databases to do things like backup, to do restore, failover, and failback, all these standard things that normally administrators have been doing themselves or manually. So if you're choosing between Helm and Operator, take into account what the user experience should look like, how users should be able to install and interact with your software through configuration. Is it via the Helm CLI or via a custom resource? And also think about the administrator persona, the one who's going to install and own your application on the cluster with, potentially revenue-bearing consequences. So an operator allows you to really add that custom logic and orchestration post-installation or doing complex updates and upgrades where sequence steps need to be followed, with the state of the application in mind. That's the big difference. Your operator is aware of the application, right? And it can react to things like errors in the log message or spikes in the metrics or various parts getting reconfigured. So this makes it really well suited for long-lived workloads, especially in multi-tenant environments, because the operators run with their own permissions. They don't need your permissions. They need permissions just enough to create the objects they are interested in. And they certainly shouldn't need cluster admin. On the other hand, an operator can be quite overkill, especially for things that are rather static and not changing a lot. So static deployments or one-off installs in your one-person development cluster or things that don't really need any kind of data operations like runtimes and frameworks aren't usually things you write operators for. Also, all these benefits of, application-specific operational logic come with a little bit of a price, because an operator is programmed, right? So you need to write actual code in order to do it. And what you do in that sense is you're talking to the Kubernetes API, right? And you're usually writing that in Go code because Kubernetes is written in Go and it has the most mature library ecosystem. So this is kind of a steep entry barrier into this game of, self-running, self-managed workloads on a cluster. And it would be really nice if there would be a way out of that where we can leverage the simplicity of Helm with some of the operator like behaviors that I've shown you. And that's what we are going to do in the next step. We are going to create what's called a Helm operator. And the Helm operator is basically a developer taking a Helm chart, either their own or something that's posted online somewhere, and feed that into a container. And that container image has a binary inside that knows how to run this Helm chart and how to make it connect to a custom object that you ship with that operator. So you're going to introduce a new object which represents an instance of that chart, like any other Kubernetes object. And whenever that appears, the operator will start to kick in and deploy or modify a release of that particular Helm chart, right? And you can do all of this without actually writing a single line of code. Sounds too good to be true, so let's take it for a spin and see how that works. So switching gears back here to my console. Gonna collapse that folder, have prepared another directory here called Operator. So I'm also going to switch to a different namespace in my OpenShift cluster. And now I'm going to create a new operator project. I'm going to create a Helm operator. What I'm going to do is I'm going to install the Operator SDK, and surprise, I have it already installed. Always a good idea to install your own products as a product manager. I'm going to use the SDK to create a new project called CockroachDB. It's going to be of type Helm, and I give it the location of an existing Helm chart, which is the same CockroachDB chart that I've used before, right? And that's going to do a couple of things. It's going to scaffold a bunch of stuff on my disk, which I'm going to walk you through, which is getting used to create an operator. So now I have a new subdirectory called CockroachDB. And in there, I have a directory called Helm charts. And that Helm charts directory holds the CockroachDB Helm chart as I downloaded it before with the Helm pull command. It's the exact same thing. It's not modified in any way, nor do you need to modify it in any way. You can just take it as is. What it also generated is a build directory in which there's a single file, which is a Docker file. That Docker file is basically creating the operator container image, right? And it's been scaffolded for you. So that's the second out of two steps that you need to do in order to create a Helm operator is build that container image. And there's not a lot of things going on here. See, that's just a 5-liner. And what it does, it's basically copying your Helm chart inside the container image and making it available to that operator base image. It's also copying another file here that's called watches.yaml. And that's a magic file. That's where the wiring happens between your Helm chart and a custom resource that your operator ships with. So this watches.yaml, again, it's very simple, just 5 lines. Basically tells the operator whenever you see an object called CockroachDB of the group Helm.Operator SDK in API version v1 alpha 1, you're going to create a release of the chart that I'm pointing to you here. Whenever you see a modification to an existing object of type CockroachDB, v1 alpha 1, you update the existing release of the chart with these changes. That's what this wiring is, right? That's how you tell your Helm operator which Helm chart to use and to which object to look for in the cluster. And that's basically all there is to it. So I can just change in that directory, build that container image, and I'm done. I have just now built an operator. So the only thing that's left to do is deploy that container into my OpenShift cluster and try it out with one of those custom objects. Now, fortunately, the SDK has scaffolded all the manifests that are required to deploy that operator for you. So you see an operator is nothing else than a regular deployed workload in the cluster. And if you look at the scaffolded stuff, it's really not that complicated. It's a deployment, right? This thing should get modified with the actual location of the image that I just produced. So definitely replace that image string here. And that's it. If I apply these manifests, operator, role binding, and the service account, that instantiates an operator on my cluster. Now, I'm cheating a little bit here because I told you earlier that operators run with their own privileges, which is great for security, right? And the SDK tries to do its best job to follow the least privileged principle when it generates the permissions for that operator. It essentially looks at the Helm chart and looks at all the objects that it touches and tries to guesstimate what permissions are required. And it usually does an awesome job in doing this. But some things are not easily determined by just looking at the YAML. Some things are kind of indirect, like in the case of CockroachDB, it's using a stateful set in order to deploy the database, and that stateful set has a conditional block where you include volume claim templates. So in order to do that, whoever creates that stateful set also needs get privileges on the storage class API in Kubernetes. That's something that the SDK couldn't quite figure out from just looking at the templates, because you would actually need to render them to see how they look finalized. But usually that process is something you don't need to worry about. It's usually correct. And if it's not correct, and if it's missing something, you'll find out very soon when you try to spin up the operator that's actually trying to deploy a release. You'll see error messages in the log that tell you exactly which permission it's missing. So, but as said, usually this is correct, and you don't need to do anything here. Also, for convenience, the SDK has generated an example manifest for you how you would use that resulting operator. And if you look at it, this looks very familiar to Kubernetes users, right? This is how all Kubernetes object definitions look like. You have an API version, kind, metadata, and a spec section. And in that spec section, there's basically a copy and paste of the entire values.yaml. So you can use any value from the chart in here, and by default, the SDK copied the example values in this thing. So you have a comprehensive look of what you can actually change in this chart. Enough of the talk. Let's actually take this for a spin in my cluster. Let's actually change projects here real quick. I already did that. And go one directory up where I already prepared my manifest. The operator is actually already installed here. Just to save some time, I did that beforehand. So if you do noc-get pod, you see the operator pods running here, has even a speaking name. And you also see that there is a new type available in the system called CockroachDB. So I'm asking Kubernetes, give me all your custom resource definitions. It's usually a long list on an OpenShift cluster, but I'm looking for mine here, which is CockroachDB. It's taken from the project name that I gave to the SDK, and I see it's present on the cluster. So that tells me I can actually now create a CockroachDB by just creating a Kubernetes object. So I'll do that. Again, here's that file. And I'm simply going to do oc create -f my database.yaml. And that creates a CockroachDB object. And that behaves like any other object in Kubernetes, right? So if I do oc-get CockroachDBs, I see, yep, there's an object like that. I can do a describe on it and see its status, right? First, you see it's been processed by Kubernetes. I've got some additional metadata to it. The spec section we have seen before. And it also has a status section of which a couple of conditions got added by the operator. First is initialized, and which tells you the operator started seeing that object. And second is already install successful, which means the operator has successfully parsed the object and created Helm release on the system for you. And even below that, you can see all the resources that it got created. But you see here, this familiar welcome message, just the same as I had before when I did the Helm install. Although I didn't even need to use Helm, right? I don't even need to have Helm installed. All I'm using here is OC or kubectl, right? And to prove that to you, that this really works both ways, I'm going to edit this object now. Maybe first, just take a look at that actually something got deployed, right? And we have a database cluster that just formed, as we had before with stateful set, services, and various pods. So then actually let me just quickly edit that object, because I again want to increase the cluster size. Let's increase it from 3 to 4. And because it's an operator, it will pick up that change and reconcile it with the situation on cluster immediately. So it will do a diff between what you specified in that file and what's happening on cluster. And there's a difference because I need an additional pod. And you see that additional pod has just been spawned as a result of that operator. So that's what an operator does, right? You can see the same thing in a non-interactive fashion if you just use a patch command. Again, I'm increasing the stateful set size 5. And again, the operator almost reacts immediately to it by spawning another pod. Awesome. So I don't even need to know that there's a Helm chart behind it as a user. I just have that object I use to control my database configuration. And it lends itself super well for things like GitOps or just replicating a setup somewhere else, granted that the operator is installed on the cluster, right? So again comes the mean product manager who's trying to sabotage this. So let me actually try to remove again the public connection endpoint of the database cluster. and see what happens. So now I actually caused an outage, right? Because I deleted the primary connection ingress to the database cluster. And unless you have monitoring set up or you got inquiries from clients who are trying to use this, you'll never notice this otherwise when it's not controlled by an operator. But I told you in the beginning that the operator not only watches the left side, which is the custom resource, it also watches the right side, right? So even when you're not working on the cluster or with the custom resource, the operator is still reconciling that release. And in a couple of seconds, it will actually restore that public service endpoint of the database, effectively remediating the configuration drift. As you can see, this just happened. And poof, we are back to normal. The cluster is still usable, right? So that's an aspect of an operator that always tries to do what Kubernetes does, right? It's the same goal-seeking, consensus-driven nature that we know and love from Kubernetes. Now it's available to any kind of managed application. And we have just done this by using a Helm chart and converting it to an operator. So in the sense of time, I'll keep it at that here and quickly show you some closing remarks. I think this is an exciting way for you to try out operators. And here's a recap of what I just did. So we saw that Helm provides a quick route to deploying a CockroachDB cluster. You need to know nothing about CockroachDB really in order to work with it. Just the Helm install command is what you're interested in, right? The Helm chart being converted to an operator is possible with a single command. We just did that using the Operator SDK, and we could almost use it out of the box by just creating a container image and deploying that on the cluster. So the operator then runs in a cluster and basically offers CockroachDB as a service. I could create hundreds of these custom resources in different namespaces, and you would get, hundreds of database instances, all controlled by that operator, all following that same resiliency against configuration drifts. And all you need to do on the client side is to use plain Kubernetes APIs, kubectl, OC, or whatever GitOps tool you have in the organization. So very nice user experience, still leveraging the ease of use with Helm and Helm charts. So that brings us to a conclusion where we see Helm is really excellent at templating and generating resources. And that's what almost all operators do at the initial stage as well. Operators, on the other hand, are excellent at keeping things in sync with the desired configuration. And they really provide this Kubernetes native experience because they are really part of Kubernetes at this point, right? You literally extended the Kubernetes control plane with that. The Helm operator gives you a journey into that operator land by allowing to leverage your existing investment in Helm or your knowledge in Helm and get some of the operator features like that communication through the custom resource, which lends itself super nice for automation, as well as this resiliency and goal-seeking nature that reverts any changes that have done by being bypassing the operator. You can do this by writing without writing a single line of code entirely using the Operator SDK, and that would be your first step into that world of managed services on a cluster if you so desire and if you have those needs. If you want to know more about that, visit SDK-operatorframework.io. That's where you'll find documentation for all of these. We also support writing operators in Ansible and, of course, Golang. So give that a try, check that out. It's super easy to get started. And as you can see, I get a really, really nice user experience out of it. With that, I'm going to end my presentation. Maybe you have some questions.
The one question I had is specifically around, you mentioned the reconciliation loop, right? In other words, there is that concept that it's constantly, is it polling, looking for those changes in the CRD? Can you describe that looping process a little bit more?
Sure. So Kubernetes is event-driven, right? That's why you saw a little bit of delay actually when I initially deleted that last services and waited for it to come back. So it's event-driven, and to make this thing scale, these events end up being in a queue, and that queue is regularly watched by that operator. And sometimes it misses events because it could be busy with other things or just got a schedule slot to see the event. So we'll just get that in the next loop. So it's not polling, it's basically event driven, and you can subscribe to essentially any kind of event in the system. So the Helm operator subscribes to its own resource, which makes sense, right? But you could also write operators that subscribe to events for namespaces getting created. So I think one of my colleagues actually wrote a namespace operator, which watches namespace creation events and applies some, default configuration to that namespace. So things like project limits are set automatically without you needing to remember that. That's an operator watching custom, or watching built-in sort of, types via events, and they usually end up in a queue.
Yeah, okay. Well, and actually what you just said there is very interesting, and I would love to dig into that further, but actually we do need to save some space for Josh, who will be up next at the top of the hour, and we're going to talk more about operators in just a few more moments. We're going to go get him set up. But I thank you so much for that. It was an excellent presentation. So great stuff here. I really enjoyed it, and it was really neat. I've not actually seen the taking of a Helm chart and basically making it an operator so easily. I hadn't tried that with the Operator SDK. I did add the links to the chat so people have access to all the links. We will publish the slides at the appropriate time at the developer's website. You'll see those there. But I thank you all for your time. Daniel, really awesome stuff.
Thanks for having me. Have a great day.
All right. Well, we're going to get out of here, but we will be back online in just a few more moments with the next session. See you for another DevNation coming soon.
Thanks, folks.